Introduction to Programming!
The heck is a state machine? It is a simple programming pattern that forces your application to have states. This thing is so powerful that you really just want to use it for complex user interface purposes. The following text emphasizes that a state must be described by a verb so that you never confuse it with an action that moves your application into that state. So you never want to have a state called think, because that's what the action is going to be named as. Your state should be thinking. You're in a state of thinking. And to get into that state, you issue a command, think. But let us take a step back. A machine is something physical. It is tough, limited, inflexible. A nuclear power plant is a good example of a machine. It has turbines that must be spun by steam to generate electricity via magnets. But it requires radioactive materials to heat the water. Turbines, no matter how advanced, can't work without steam. Nuclear power plants are rigid, limited. They are not even nuclear, not really. They are just steam power plants that are heated up by nuclear materials. A machine is hard, inflexible. A state is what you think it is, but we have to use a verb, an activity, for its name. If you are feeling philosophical, then a good state name is thinking, because it's simple. You always want to choose simple words. You don't want philosophical state, then your command to enter that state becomes philosophize. No, you want to keep it simple. Now, onto the state machine and the problem that messes everyone up. The most fantastic state machine, especially if you are reviewing your programming knowledge, is the traffic light. Let me underline the light cycle here because we're jumping all over the place. Green, yellow, red, and back to green. The green light does not turn to red. It turns to yellow to warn speeding drivers that the light is about to change. But the red light does not warn the stopped drivers that it is about to become green, because they are stopped. They are not in danger. There is no need to warn anybody here. All too often, inexperienced writers, teachers, and professors create a state named red to explain all of this. And it has a green action in it, which is how the light works. But the naming here is wrong. This is a huge disaster because it says nothing about the machine, and it is confusing and often pushes people away from using state machines. State machines are really important in computer programs. It's really not a good idea to program without them. And, little applications can also use state machines to introduce some rigidity, even though it's so powerful that it works really good for advanced user interfaces, it will still make a little program better. Let us start with a green light here. And let us call this state driving. Not the best name, but it works great for our purposes. In the driving state, we have a warn action. That is it. We do not have a stop action here. That would violate the integrity of the traffic light. Under driving state, we can issue warn to enter the warning state, and only in the warning state we get the stop action. And issuing the stop action puts us in the stopped state. Yes, but not before, not after. We have to be in the warning state. Very cool. And here we get a drive action. And when issued, we enter the driving state again. Your program doesn't get mixed up in here. You can't issue the wrong action at the wrong time. Lots of programs can benefit from this. Think of an action as a shout. It is a short thing that you snap. And a state is something that takes a while. It is an activity performed over some stretch of time. You must never have a sleep state. That is a command name. The state name is sleeping, driving, warning, and stopped. Finally, a state machine can go through a complex cycle of states without causing any trouble, because you can't issue the wrong action at the wrong time. It won't let you go from driving to stopped during the driving state. You can only issue the warn action. You can't issue the stop action. And then when you transition to a warning state, you can issue stop, but you can't issue any of the other actions that are in the other states. Very cool. In complex user interface programming, a state machine can protect the integrity of your entire user interface. You will never be surprised by users not being able to click the save button, because with a state machine, you have that licked on the back of an envelope even before you sit down to programming with your user interface component.